All right, here we go. More in chapter 4, scale drawings. Okay. And our essential question is, what is a scale drawing? Okay. When you're in the classroom, you see scale drawings, that boat that I have on the wall when you walk in the door. That's a perfect example of a scale drawing. We couldn't fit that 55-foot boat in here, but we can draw it down the scale and put it on a map on the wall. Okay. So what is a scale drawing or model? It's a drawing that represents objects that are too big or too small, okay, to be drawn or built to actual size. You know, with electronics today, things get so small that sometimes we have to blow them up so we can look at them and better describe them, take a look at them. So when we're talking about these scale drawings, uh, what is the scale? Okay, when we say the scale, that's a ratio that compares the drawing measurements to the actual measurements. Uh, if you can take that boat, for example, when you are finding, when you're building that model, okay, and we want it to look exactly like the other one, there's going to be a certain scale, okay? It might be 1 inch equals 10 feet, might be 1 inch equals 5 feet, it be whatever you want it to be, okay? But since you can't actually draw or do that 55-foot boat, we might say that 1 inch on our drawing represents 5 feet in actual, okay? And then you use that to draw everything out, and then at the end, it'll look just like the original, okay? Let's take a look at some examples of finding this or using this, okay? Get this squared away here. Using a map scale. Example, on a map of Florida, the map scale is 1 centimeter equals 20 miles. Upon measuring the map distance from Melbourne to Miami, we find it to be 9 centimeters. So what's the actual distance? Okay, remember we said the scale is a ratio. A ratio is a fraction. So we're going to, since we were talking 1 centimeter equals 20 miles, I'm going to write my ratio or fraction as 1 centimeter over 20 miles. Now I make note of this over here that I wrote centimeters to miles because I have to keep that same ratio every time I rewrite it. Okay, I got to make sure I keep the number of centimeters over the number of miles. So if 1 centimeter on the map actually represents 20 miles, what will 9 centimeters on the map represent? What distance is it actually? Okay, so this is how I set it up. So what I've created here is a proportion. Okay, we've talked about that a little bit already. And we solve the proportion by cross multiplying. Okay, we're going to take d and bring it up times 1 here, and 20 times 9. We've done some of this already. So 1 times d is 1d. 20 times 9 is 180. There's nothing to divide out here, so d is 180 miles. Okay, that's how far it actually is. All right. So we start out with by knowing what our scale is. What if we don't know that scale or scale factor? Okay, what is a scale factor? It's the ratio without the units in simplest form. Okay, you must get the ratio in the same units to simplify. Okay, so like if I wanted to do this up here, I'd have to convert one of them either to centimeters or miles. Let's take a different example. What is the scale factor of a model car if the scale is 1 inch equals 2 feet? Okay, well, the scale factor has to be in the same units and then simplified. Okay, get in the same units. So if I'm going to write my scale as a ratio, a fraction, 1 inch to 2 feet, then I've got to put them both in the same units. Okay, now it's a whole lot easier to change 2 feet to 24 inches than to try to create a decimal or a fraction for how many feet is 1 inch. Okay, it's 1/12. It gets messy. Okay, let's take the conversion factor, 2 feet equals 24 inches, so we can keep a simple fraction here, 1 over 24. That is simplified. We can cancel out the inches, so we're left with 1 over 24. Okay, that's our scale factor, 1 to 24. Units are the same. That's the same as 1 inch equals 2 feet. Okay, let's take a look at a real world example here. Leah is making a scale model of the solar system. The sun's diameter is 1,391,900 kilometers, and she wants to make it 10 inches. So she wants this to be 10 inches on her model. If Mercury has an orbit radius of 57,950,000 kilometers, how many feet away from the sun's center will Mercury be in the model? Okay, so we need our scale factor first. Okay, so we said we wanted 10 inches to represent 1,391,900 kilometers. Okay, so what I'm going to do first here is I want to know then 1 inch is how many kilometers. Okay, so I'm going to set that equal. I'm going to cross multiply here to solve my proportion, just like we did up above in the first one. So I get 10x, and then 1 times that is 1,391,900. Divide the 10 out, cancel it out, I get 139,191 kilometers. So 1 inch equals 139,190 kilometers on our model. Okay, that's going to be the scale factor on our model. Okay. Find Mercury's distance away in inches, then convert to feet. So we know how far. Picture. We know that Mercury has a radius of 57,950,000 kilometers. Okay, so how far is that in inches so we can represent it on our model? Well, 1 inch is this. There's our scale. Okay, so we're going to set up our two ratios, set up our proportion. We're going to cross multiply. Remember, you bring the bottom up to the top, bottom up to the top. So we get this. Divide this out, 139,190. Okay, and what you get is 416 inches. Okay. So 416 inches is that radius on our model. Well, 416, this is 416, kind of wrote over it. Divided by the 12 inches in a foot tells us it's 37.4 feet is what it will actually work out to be in our model. Okay, so that's what the radius will be for Mercury from the sun. Okay. Now let's look at a couple examples here. An engineer makes a model bridge using a scale of 1 inch equals 3 yards. If the bridge is actually 50 yards across, what will be the model length? Okay, so I'm going to go 1 inch over 3 yards. Okay, there's my scale. Again, I make a ratio, a fraction. So how many inches will it be if it's 50 yards? So I went inches over yards, inches over yards. Cross multiply. So I get 50 equals 3 times x. Divide out the 3. 3 goes into 50 16 times with a remainder of 2. So that's how many inches. Okay, x inches. That's how many inches it'll be on our model. Whoops. Sorry. Okay. Set up my cross multiplication there. I get 50 equals 3x. Divide the 3 out here so it cancels. 3 goes in there 16 times with 2/3 left over. Okay. So that was knowing the scale. You can either find actual length or model length using that. Here we want to get back to finding the scale factor. Okay, remember, no units in the scale factor. We do that by getting them both in the same unit. So 1 inch equals 4 feet. Well, 4 feet is, it's easier to put this into inches than try to put that into feet. So 1 inch is actually 48 inches. Our inches cancel out. We get 1 over 48. There's our scale factor. Okay. So we changed our 4 feet to 48 inches, cancel the inches out, 1 over 48. Here we've got 1 centimeter is 15 millimeters. And you get a choice here. You can change, you know that there's 10 millimeters in a centimeter, so we can make this 1.5, but if you don't want a decimal in there, we can also make centimeters here 10 millimeters. It'll work out the same either way because we're using equal measurements. The millimeters cancel. 10 over 15 is 2/3. Okay, units cancel out. There's our scale factor. All right, we're going to be looking at more of this in class. We'll get after that starting tomorrow.